Galileo di Vincenzo Bonaiuti de Galilei. The life and legacy of a revolutionary scientist. Early life and education. Galileo Galilei, one of the most influential figures in the history of science, was born on February 15, 1564, in Pisa, Italy. He was the eldest of 6 children born to Vincenzo Galilei, a well-known composer and music theorist, and Giulia Ammannati. Vincenzo encouraged his son's education, particularly in mathematics and music, both subjects in which he excelled. However, like many families of the time, the Galileis were of modest means, and Galileo's future was uncertain. Initially, Galileo's father intended him to study medicine, a field that was both prestigious and financially promising. In 1581, at the age of 17, Galileo was sent to the University of Pisa to pursue a medical degree. However, his interest in medicine soon waned, as Galileo found himself more captivated by mathematics and natural philosophy. A pivotal moment came when Galileo reportedly noticed a chandelier swinging in the Cathedral of Pisa and realized that the time it took for the chandelier to swing back and forth was independent of the size of its arc. This observation led to his early work on the study of pendulums. Abandoning medicine, Galileo turned to the study of mathematics, under the mentorship of Ostilio Ricci, a court mathematician. Galileo's shift in focus was not warmly received by his family, who worried about the lack of lucrative prospects in mathematics. Nevertheless, Galileo's passion for the subject was undeniable, and by 1589 he had secured a position as a professor of mathematics at the University of Pisa. The birth of experimental science. During his time at the University of Pisa, Galileo began to challenge established Aristotelian physics. The prevailing scientific views of the time were heavily influenced by Aristotle, who argued that heavier objects fall faster than lighter ones. According to tradition, Galileo disproved this theory through a famous experiment in which he dropped 2 spheres of different masses from the Leaning Tower of Pisa, demonstrating that they hit the ground simultaneously. While the actual details of the experiment remain debated, Galileo's findings were revolutionary. He proposed that objects fall at the same rate regardless of their mass, a principle later refined by Isaac Newton in the theory of gravity. Despite his groundbreaking work, Galileo's outspokenness against Aristotelian doctrine did not sit well with the academic establishment. In 592, after clashing with colleagues and the conservative attitudes at Pisa, Galileo moved to the University of Padua, where he would spend the next 18 years teaching geometry, astronomy, and mechanics. It was during this period that Galileo's most important work in mechanics and astronomy began. Galileo and the telescope. One of Galileo's most significant contributions to science came in 609 when he heard about the invention of the telescope, a Dutch device that allowed distant objects to be seen as if they were closer. Without ever having seen the device himself, Galileo quickly constructed his own improved version, which could magnify objects up to 20 times. With this telescope, Galileo turned his gaze to the heavens, and what he observed would forever change the course of astronomy. In a series of observations in 609 and 610, Galileo made several groundbreaking discoveries. He observed that the moon's surface was not smooth and perfect, as Aristotle had claimed, but rough and mountainous. He also discovered 4 moons orbiting Jupiter, now known as the Galilean moons: Io, Europa, Ganymede, and Callisto. This was a direct challenge to the geocentric model of the universe, which placed the Earth at the center, with all celestial bodies orbiting it. Galileo's observations of the phases of Venus provided further evidence against the Ptolemaic system, which was based on the idea that the Earth was at the center of the universe. Instead, his findings supported the heliocentric model proposed by Nicolaus Copernicus, which argued that the Earth and other planets revolved around the Sun. Conflict with the Church. Galileo's support for the Copernican model placed him in direct conflict with the Catholic Church, which held that the Earth was the center of the universe, as per Scripture. In 616, the Church officially condemned Copernican theory as heretical. Galileo was warned by Cardinal Robert Bellarmine, a prominent church official, not to teach or defend heliocentrism. For the time being, Galileo complied. However, Galileo continued his research and published his findings in 632 in his book Dialogue concerning the two chief world systems. The book was a masterful work of scientific reasoning presented in the form of a dialogue between three characters, one who supported the Ptolemaic system, one who supported Copernicus, and a neutral observer. While Galileo claimed the book was an impartial discussion, it was clear that he was advocating for the Copernican system. The character who supported the Ptolemaic view was portrayed as a fool, and many believed this character was a thinly veiled caricature of Pope Urban VE, who had previously supported Galileo but felt personally attacked by the book. The publication of the dialogue was the final straw for the Church. In 633, Galileo was summoned to Rome and put on trial by the Inquisition for heresy. Under threat of torture, Galileo recanted his support for heliocentrism and was sentenced to house arrest for the remainder of his life. According to legend, after his recantation, Galileo muttered, per si muove, and yet it moves, though this is likely apocryphal. Later years and legacy. Although condemned by the Church, Galileo's scientific work continued. While under house arrest, he wrote discourses and mathematical demonstrations relating to two new sciences, which summarized much of his work on kinematics and material strength. This book is now regarded as one of the founding works of modern physics. Galileo's health deteriorated in his later years. By 1638, he was blind, likely due to cataracts and glaucoma, and he was increasingly frail. Nevertheless, he continued to correspond with other scientists and remained engaged in the scientific debates of his time. Galileo died on January 8, 642, at the age of 77. Galileo's death marked the end of one of the most important scientific lives in history. Though he had faced opposition and persecution during his life, his ideas eventually triumphed. Galileo's support for the Copernican model and his development of the scientific method laid the groundwork for modern astronomy and physics. His emphasis on observation, experimentation, and the questioning of established authorities set the stage for the scientific revolution. The scientific method and Galileo's influence. One of Galileo's most lasting contributions to science was his development of the scientific method, which emphasized observation, experimentation, and mathematical analysis as the means to understanding the natural world. Prior to Galileo, scientific inquiry was often based on philosophical speculation or appeals to authority, particularly Aristotle. Galileo, however, insisted that knowledge of the natural world could only be gained through empirical observation and mathematical reasoning. This approach was revolutionary and laid the foundation for modern science. In mechanics, Galileo's studies of motion were particularly influential. He formulated the law of inertia, which stated that an object in motion will remain in motion unless acted upon by an external force. This principle was later incorporated into Newton's first law of motion. Galileo also conducted experiments with inclined planes, discovering that the distance an object traveled was proportional to the square of the time it had been in motion, a key insight into the nature of acceleration. In astronomy, Galileo's work was groundbreaking. His observations of the Moon, Jupiter, and Venus provided strong evidence for the heliocentric model of the solar system. His discoveries were initially met with skepticism, but over time, they became widely accepted as the evidence in their favor grew. Galileo's work paved the way for future astronomers, including Johannes Kepler and Isaac Newton, who would further refine our understanding of the universe. Rehabilitation and modern recognition. Despite the Church's condemnation of Galileo during his lifetime, his ideas gained increasing acceptance in the centuries following his death. By the 18th century, the heliocentric model was widely accepted among scientists, and Galileo was celebrated as one of its pioneers. In 1992, more than 350 years after his trial, Pope John Paul II formally acknowledged that the Church had erred in condemning Galileo. This act of rehabilitation was a symbolic recognition of Galileo's role in the advancement of human knowledge. Today, Galileo is remembered as the father of modern science. His willingness to question established authority and his insistence on empirical observation as the basis for scientific knowledge are hallmarks of the scientific method. Galileo's discoveries in astronomy, mechanics, and physics continue to influence the way we understand the world and the universe. His legacy is not only one of scientific discovery, but also of intellectual courage in the face of opposition.